In this final portion of the activity, we're going to be asking students to really think in a computational way. Recalling back to the prior activities where students were beginning to think about the orbital arrangement of the 4 MMS spacecraft with relationship to the Earth. Well, if you remember, and if your students would be prompted by you for this, there were also, besides the fact that the MMS spacecraft were represented in relative position to the Earth, they were also represented in relative position to one another in that orbital plot diagram that we saw in that browser view, which we're going to go back to in a moment. So in this final piece, we're asking students to actually look at some of the plot data, instrument data that's coming from the data sets. And the data is very high level. These are things that NASA scientists are able to read and see in their sleep. But for students that are in grades 4 through 8, it's really about looking at the visual representations and making some connections. So one of the things that you can have them do, and what they'll be led to, is trying to find if there are places where there are anomalies in the data. So for an example, in the final activity, activity 4, they're going to be led to look at the quick plots where they're going to pick a date that they actually saw data being available under the availability chart. And what they've been asked to do is look at the plot type of all from each satellite, or of each MMS spacecraft. So here we see that there is clearly a peak of visual representation of data here. If we keep the same date and we move this to MMS2, you'll notice that that jumps 2 relative units to the left. Do the same thing here. You see it doesn't jump nearly as much. It's actually about the same, and in fact it's about the same for spacecraft 4. So 1 comes all the way over here, about 2 units to the right. So it's not as important for this exercise for the students understand what those units represent or what data is being represented here, as much as it's clear that spacecraft 1 is an anomaly when compared to 2, 3, and 4. So let's take a look at the date. It's February the 17th of 2017. So I'm going to hop on over to our Science Data Center again and go back to the Orbit plot browser that we worked with in one of our prior activities. If I were to go to that and again set that same date, we're going to go to the 17th of February. We're going to go ahead and just keep the plot at 0, 0. What we notice here very quickly is that MMS1, if you remember, is the satellite that was actually showing an incremental difference, a significant incremental difference, and the other 3 were actually pretty similar to one another. Wasn't that interesting? Those others, relative to one another, are actually pretty close to one another in terms of where they fall in that location on the circumference there of the orbit. So as we begin to ask students to think about cause and effect, while it may or may not be because of that, what's important to start seeing is that students are making connections here between the geometry of the physical arrangements of the MMS spacecraft to one another, and why that actually may be leading to what we're seeing here as a difference in data between satellite 1 and the other 3. So this would be a good date and example to be able to show to your students. Again, February 17th, 2017. You can use this one as a great example to demonstrate to your students so that then they could be charged with finding another example of that on their own.